Welcome back, everybody. This is the last video in a four-part series on performing operations on real numbers. In this video, we're going to talk about some nice properties of operations on the real numbers that can make our lives a little bit easier. But it does require our information from the third part of this video, so if you haven't seen it yet, please go check it out. If you have, let's get started. Perhaps, like myself, you remember seeing these three words on your benchmark tests in high school and never remembering what they meant. The commutative, associative, and distributive property are three really important properties of addition and multiplication that help us to simplify algebraic expressions. And in the typical math fashion, they are complicated words that make an easy idea to comprehend really difficult to understand. So what I have written here is the more formal definition of these properties, but I'm going to walk you through it in a way that's a little bit simpler to understand. The commutative property says that if a and b are real numbers, then a plus b and b plus a are the same, and ab and ba are the same. Really what this is saying is that we can add numbers in any order we want, and we can multiply numbers in any order we want, and we get the same thing. And the associative property is kind of just a big extension of that. If a, b, and c are all real numbers, then a plus b plus c is the same as a plus b plus c. Similarly, a times b times c is the same thing as a times b times c. In other words, we can group up particular additions in a big chain of them in any way that we want, right? So when I have many terms that are being added, I can add them in any order. If I have many terms being multiplied, I can multiply them in any order. Last but not least, the distributive property is another really important one that explains to us how multiplication and addition interact with each other. So if I've got three real numbers, a, b, and c, and I have a times the sum b plus c. Basically what this is saying is I could either add b and c together and then multiply a, or it might be easier or more convenient to multiply a to b and c and then add their results. Right? So I can distribute a across the sum. And notice now I have a times b and b times c. Oh, that should say a times c. My bad. Now, a little bit of vocab before we take a look at some examples. The terms in an algebraic expression are just the pieces that are separated by addition and subtraction. So in this one up here, AB is a term and AC is a term. Now, when we have numbers in front of those terms, we call those numbers the coefficients of that term. So let's get some practice with these vocabulary words. For each of the following, let's identify each term and its coefficient. We'll do part A together. Remember, my terms are just the things separated out by addition and subtraction. So here, I've got one term, another term, another term, and another term. Notice I can kind of think of there as being an imaginary little addition in front of these minus signs. So the negative sign goes with the coefficient of each term. For the first one, there's no tricks afoot. The coefficient's just 7. And here, I'll write it in a color that matches. For the second one, though, notice I very carefully chose my words with separated by addition. So, -3 is the coefficient of the second term. The minus sign stays with the term. When I don't see a coefficient, there's really an imaginary 1 there. And last but not least, if I have just a number, well, the whole number is the coefficient. The whole term is the coefficient, -4. See if you can use these tips and tricks for part B. Identify each term and its coefficient. Pause the video here to see if you can do it on your own. Typically, it is true that letters are used to represent variables, but sometimes it makes sense for us when we're trying to generalize things to use letters for constants as well. And we'll see some examples of that, and I'll be sure to point them out as we move forward. I know that that makes this one a bit of a confusing problem, but it will show up on your homework, so I want to make sure that you're aware of it. In the first term, that said, since a is a constant, it is the coefficient of the first term. X is a variable. We weren't given any information about x. Same thing with the second term. B would be the coefficient because we know it's a constant. X, on the other hand, is unknown. It's a variable. And in the third term, plus C, well, the whole thing is the coefficient, C. And last but not least, the last term didn't really have any tricks involved. The coefficient there is -13. Let's put all of this stuff together to simplify each of the following expressions. Let's do the first one together. Using our commutative, associative, and distributive properties, I can combine like terms. Notice I've got a 6x, and I'll use a highlighter here. I've got a 6x and a 4x. Let me do sort of a thought bubble off to the side here. If I've got 6x plus 4x, I can write that. Notice I've got a common factor of x. I can write this way. And now I know 6 plus 4 is just 10x. So I'm almost using the distributive property in reverse. And in fact, that's actually exactly what I'm doing. But I have an easier way to maybe digest how to combine like terms. And I do not mean to insult anyone's intelligence by saying this because I still use this trick. If I have 6 grapes and somebody hands me 4 more grapes, how many grapes do I have? 10. Right? I have 10 grapes. But now I'm just using x to stand in for the grapes. Similarly, if I have 10 cookies and somebody gives me 2 more cookies, then I end up with 12 cookies. Only now I'm using x squared instead of cookies, and I think maybe I'm hungry and need to go grab a snack. So altogether then, if somebody gave me 6 grapes and 10 cookies and 4 more grapes and 2 more cookies, in the end, I've got 10 grapes and 12 cookies. It wouldn't make sense to say I've got 22 grape cookies, right? I wouldn't write 22xx squared. Instead, I can only combine like terms. I'm only going to pile up my grapes and my cookies separately. So this would be the final expression. Go ahead and pause the video here to see if you can get part B on your own. In this problem, I had a little bit of extra work to do here because the expression wasn't fully simplified, right? And on top of just combining like terms, I first need to distribute that 4 and that minus sign, right? I am multiplying 4 by both terms here. So I have 4 times 5y, which is 20y, and 4 times minus 3, which is negative 12. That's how our distributive property works. Same thing over here on the other one. It may be tempting to write the plus 3 here, but that would be incorrect because I'm actually subtracting both of the terms in that set of parentheses. So the minus sign gets distributed to both. Once we're at this line, 20y minus 12 minus 6y minus 3, things become a little bit more clear. Now I have like terms to combine. I've got a 20y and a minus 6y. Those combine to give me 14y. And I've got a negative 12 and a negative 3, which combine to get me negative 15. From this video, you should be taking away how to use the commutative, associative, and distributive properties to simplify algebraic expressions. And this is going to conclude our series on operations on real numbers. In the next series, we're going to be discussing radicals. Catch y'all on the next one.